All right. What I do want to see, prove to me that you do actually know how radicals work. Because you need to know how to work radicals before we get into today. So at the beginning of 4-6, there's a few problems there. Figure it out. Are you already done with all of them? So,
Oh, I need my notes.
this is pre-calc. I don't know what are you looking for? Did you turn in a different file? That is a different file. Okay. Okay. I will need to see that after class. Yes. Oh. No, you were just late. That's why. Bad Harrison. Give me those. How's that working for you?
We don't have to do with the negatives. Or just go negative.
What does 5 equal?
5.
What does negative 5 equal?
Negative 5.
What's the square root of 32? 4 root of 2. So a negative square root of 32 is just negative 4 root of 32.
Yeah, Brooke said she got it, so.
I don't know. Okay, yes, I got Okay, that is 10 for 14. More.
It's either this.
This one?
Okay, I just handed back quizzes 1 through 4 as well. It's a really bad Vader. It's the Vader stamp of approval. The student has become the master. Once I was but the learner, now I am the master. Four 2754. Don't worry too much if you can't get the stuff with the variables yet. We're going to review that again in chapter 6. If I'm squaring a radical, remember you have to square what's inside and outside. That's not 54, that's 108. There we go. Because square root of 27 squared is just 27, but then 27 times 4. Square what's outside, square what's inside. And then they get multiplied together. Okay? 5 and 1 especially, that's stuff you have to know today. This one and this one. You have to know those today. You have to know how to rationalize, you have to know how to simplify. The other stuff, we actually hit radicals again in chapter 6. Okay. I'm guessing we're cool on everything except 15. Okay, you saw that I reduced the fraction. If I have square root of 50 over square root of 7, that's 25 by 2. 5 comes out, so I'll call it 5 square root of 2 over square root of 7. No radicals downstairs, stir up the girls, give them bad ideas. Multiply by square root of 7 over square root of 7. What's inside radical land stays in radical land. And square root of 7 by square root of 7 is just 7. Okay. We have to know how to work radicals for today. That's why we did a little timeout and did some work on it on Thursday last week. Okay. The book just assumes that you are fluent with this because you learned how to do it in Algebra 1 and you should have been using it nonstop in geometry. I know that's not the case. I know our geometry teachers are a little more lenient about just going with decimals, and it did you a disservice because now maybe you're a little shaky on radicals. Okay, we got to know how radicals work to do today. So, the reason we have to know how square roots, specifically square roots, we're not even at third root and fourth root and fifth root yet, we're just at square roots. The reason, that is big yes. Yep. The reason we have to know how square roots work is because I can solve using them. If I want to get x by itself, old school operations tell me subtract 10, divide by 4, square root. But here's the catch, and I want you to put a big honking neon, go get your little flags and smack them in there. Okay, this is a big deal. If you ever put a square root in, you have to put plus or minus. Because square root asks the question, what times itself makes this number? Both a 3 and a -3, when squared, will make 9. So if I'm simplifying radicals and they're just hanging out there, if I just saw square root of 54, I would call that 3 square root of 6. But if I was saying x squared is 54 and then I put the square root in there, now I have to have the plus or minus because I put the square root there. Okay? So if the radical is already there, you're good. Just do whatever it says. It's called the principal root. But if you ever put the square root there, you have to include plus or minus. Okay? Because as we've seen so far, all of these quadratics we're dealing with, they always have two solutions. Maybe it happens twice, maybe it's a repeated solution, but it still has two of them. So I need plus or minus whenever I put the radical in. Now here's why we had to know it. Add 5, divide, and if I had backed up to last Wednesday and said, now what? How many of you would have said 3.1 blah, 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 because that's what your calculator told you?
No, never.
Okay. I have plus or minus because I put the square root there. Square root of 10, can it be simplified? So it's just square root of 10. That is the official correct answer. Now, I know it's the official correct answer because I can say x minus the first 0 times x minus the second 0, so minus a negative means plus. If I FOIL this out, x squared plus square root of 10x minus square root of 10x minus 10. Those middle terms will cancel out. Okay? Just like if I took x minus 3 times x plus 3. Right? Like it'll get me x squared minus 9. I have to be able to justify this. If you had just said about 3 point something and then tried to do what I just did, it wouldn't work. You'd get close to the answer, but you wouldn't actually get the answer. And that's why we have to know how to do radicals. So from this day forward, in my house, square root. You will have simplified fractions, simplified radicals, no decimals. Okay? Unless it's in the context of the problem. If I go into Necht Home Center and I ask for, well, I'm going to be putting a bracing on a corner flower garden. My wife's putting a little thing by the deck. I'm going to need 5 different 2x8s that are all square to 10 feet long. That might be what it actually is. I was in my garage making our custom desk for my wife, wall mounted, just last night. I'm using basic trig. I'm writing out things in terms of specific square roots. I know that the answer was square root of whatever, blah, 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 but then I would say next to it is approximately plus or minus 3 point, and I'd go 3 places. Okay. So if it's just blah, 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 do algebra, write it as a radical. If it's context of a problem, write it as a radical and then give me the decimal approximation next to it, because that's the one people will understand. Do them both. Actually, there we go. That'll do some damage. Okay. Solve both by square roots. Get x by itself, then square root. Oh my god. That's good. Alright, I can give you that one back. I didn't see a line, so I didn't realize that was your graph. Yeah, I can give you that one. Okay. Just like that. Nothing too crazy. Get x by itself, square root. Since you are putting the square root there, you will put a plus or a minus. Okay? Now, so far, none of those we've had to simplify. We might have to do a little more. Okay, words. While designing a house, an architect used windows like the one shown here. Ah, crud. All right, who's got a book? I forget what it is. It's like... Okay. It's a... I remember the design is like this, where it's a bunch of rectangle or squares. Anyone? No one carries a physical book with them anymore. I really don't want to go all the way through Clever, because Clever works fine, but it... Who? All right. All right. I'm just gonna run through it because I need the actual picture up here. And Clever works just fine. It just doesn't work well with Pearson because Pearson's trash.
Apparently, Daddy Rivers did go.
Come on, Frank. There we go. See, I was looking at a completely different problem anyway. All right. X to X, 5, okay. I'm thinking about an entirely different problem. Okay, I want to make that better because, oof. All right, who remembers geometry? How do you find the area of this figure if that's a semicircle at the top? A circle is pi r squared, so I'm going to have length times width. Area is, there we go, plus 1/2 pi r squared. Okay. Length times width plus 1/2 pi radius squared. Oh, yes, we do. Because if my length and width are going to be x and 2x, what's the radius of that circle? No, that's a diameter. A half an x. Half an x over 2, same thing. And it also told me that the area is going to be 2766. So, 2766 is 2x squared plus, what happens when I square half an x? No. That's times 2. X squared divided by 4, right? Square the numerator, square the denominator. I'm going to have 1/2 times pi times x squared over 4. So all the numerator stuff together is pi x squared. All the denominator stuff together is 8. So altogether, I will have pi over 8 x squared. Okay, pi times 1 times x squared, 2 times 4. All I'm doing is pulling that x squared out front. Now I can combine this and call it 2766 is, now if this was 2x squared plus 5x squared, you just smash those together, right? You'd call it 7x squared. What you just did was 2 plus 5 x squared. I can do the same thing here when it's ugly and say that's 2 plus pi over 8 x squareds. Another way to think of it is factor out x squared because they have it in common. Okay. Now if this was equals 8x squared, you would just divide by 8, right? Can I divide by butt ugly over here? You got a calculator? Yeah. Do it. Now in this case, because we're talking real world context, I will allow you to go to decimal land. I can write the actual expression, but I'll tell you right now, most people aren't going to want to know that their stained glass window is something something square root of 2. No, like, no. So, grab your calculatron. Pi is right above the caret, and you will use pi. Do not use 3.14. Do not use 22/7. You're just making up numbers now. I always stop after 6.
Me and him.
Last year in geometry.
Okay.
What is it?
So I'm going to take that 2766 and I'm going to divide it by this parenthesis of 2 plus pi over 8. 2 plus pi over 8. How did I get answer into?
Like, you know.
Oh, gotcha. Okay. So let's say I don't have fancy calculator, or I don't know how to run one, but I know where the answer button is. I can take pi divided by 8, get thing, plus 2, get thing. I now have answer. I want to take 2766 and divide it by that answer. I have two options. Option 1, I can literally come up and highlight it, hit enter. Or, right above my negative button is answer. Okay. Both will work. So 1156.017. If x is approximately 1156.017, another note I would like you to make to yourself, if you ever round something, put approximately, do not put equals. It isn't the full correct answer anymore. It's the approximate answer, so I will use approximately for it. Little squiggles, it looks like a equal sign that got beat up a little bit. Okay. So, did I answer the question? What?
Wouldn't it be inches squared?
No. The area is square inches. I'm talking about the measurements, which are linear.
We're not done yet, so we have to do it.
Okay. I did not answer the question yet. What dimensions is this window? Well, it's 1156 and change wide, but it's 2312 and change tall. Is there?
Yeah, you forgot the square root.
Did I square root somewhere?
X squared. There was x squared.
Oh, we got so hung up on the calculator stuff, completely forgot that. Okay.
Attaboy.
All right. So we'll back up here, right? We had this, and we wanted the square root of it. How do I type square root of a number I already have?
Oh, wait, no.
Uh-oh.
And then you just do this. Square root
Okay.
of x and square root of that.
When I do square root, I can highlight this, or I can go all the way back to the entire thing. It's going to be the square root of that whole honking thing, right?
Yeah.
So you can square root of your answer, or you can square root of the entire calculation. Good call. So if I'm rounding to the 1000th place, this actually comes out pretty good, because now, what is x? 34. Just straight up 34. So in this case, rounding off to the 1000th place actually worked for me. We ended up with x was about 34 inches. So I will say that this window is 34 by 68. Okay. So every now and then, we are going to have that geometry stuff come back to us. What should have happened in geometry is you spend the first half on almost nonstop proof. You start with definitions, postulates, axioms. You use those to prove things about lines. Once you prove things about lines, remember all your parallel line theorems? alternate exterior angles kind of stuff. Okay, you prove all that stuff. Then you get into triangles. You do triangle similarity, triangle congruence. It's all proof. And then the second half of the class, you do some proofs with parallelograms, and then circles, and then a bunch of application of surface area and volume is what's supposed to happen. I know that didn't happen because I got kids who come up all the way to pre-calc and they still have never seen secant theorems for circles. They're easy, they just don't know what they are. The blank looks tell me that that trend continues. What is x? Okay, it was a product. Inside times outside equals inside times outside. It wasn't difficult. It was just one of those things that, you know, if we haven't seen it or not. Okay. But is this knocking a little rust off the gears? Like, you got to be able to do it. Side lengths of a rectangular window have a ratio of 1.6 to 1. How do I set up that? Yeah.
The last question asked for the dimensions. Is that a brownie point since we only wrote one?
We have.
Oh, sorry.
Did we get one for them?
Yeah, you did. I just didn't write it. Okay. Yes. So, oh, we're getting there. We're on the final countdown. I mean, you see those. They're like 4 by 5. I mean, they're good size. So, how do I set up ratio of sides? Like, what do you think? Like, if I say the ratio of guys to girls in the gym at the homecoming dance was about 2 to 5. Okay. How does that help me figure out the number of each in the room?
You just have to find the number. Either the total
Oh.
or just one.
Okay, you multiply by some scalar factor, right? And that is not known. So what do we put for I don't know in math? Okay, so if I know that the ratio of my side lengths is 1.6 to 1, then I know that 1.6x is to 1x. You did this a lot with triangle side lengths. They would say the side lengths are 3 to 4 to 5. Okay. You take it from there. Go and find the dimensions of the rectangle. Who's a what?
I remember doing this. I just haven't done it since
Oh.
middle school.
Okay. Length by width. So my area is going to be length times width.
Because I remember that equation.
Yep.
I just haven't done it since like 8th grade.
Fill in your length, width, area. Solve. Yes.
Oh, okay. So on this problem, I understand everything except where this x squared went. Because like it went.
I factored it out because they had an in common. Just like a GCF.
Oh. Oh, okay. Where did it? Why is the second one so
Okay, so if I do like 15x minus 3x, you know what, we'll do 30,
you can take
18. There we go. Okay. So I'll say 6x comes out,
Yeah.
leaving a 3, oh, no more x's, minus a 5, no more x's. I can write it here or I can write it here. It doesn't matter.
Oh, okay.
I just wrote it in front.
That's how you win a battle right there. 1764. Which one's up first? One?
What? I don't have the mental mojo to do that right now. 28, 22.4 Oh, yeah. That's a perfect square, isn't it? Sounds familiar. Yeah, it is. Meaning of life. Yo.
Where?
Wait, but is it divided by? Oh, see, that's what. I'm gonna walk geometry.
You did get signed up for it, though? You got your schedule switch? Okay. Oh, yeah, after being in here, you go do geometry and just get wrecked, freshman. Okay.
I told you, Dom. Actually, what's your plus or minus?
Now, if I'm solving just the equation, length times width equals area, plug in the stuff you know, solve for x. Remember, I just put in a square root. So technically, the solutions to the equation are plus or minus 42. But then you have to think about reasonable answers. Can I have a window that is negative 42 inches tall? No. That's why you actually say is 42 and is, what's that, 4, 3?
67.2.
Ugh. No, I can't. Not today. We've been going on like 2.5 weeks of getting woke up 2 or 3 times a night. And okay, so this is just showing you an application of that. Can you solve by square roots? Cool. All right. So here's the heart of today, though. If I can solve by square roots, that can help me when it's an entire expression squared instead of just x. Case in point, if I were to factor the left side, don't move the 25 yet. Factor the left side. What factors of 4 add up to 4? 2 and 2. So instead of, factors of 4 that add up to 4. X plus 2, x plus 2, right? And we said we can write that as x plus 2 squared. Well, if I can undo squared with square root when it's just x squared, I can also do it here. Just remember, when I put in the square root, this is plus or minus 5, and anytime I square root something squared, they cancel. I still have to finish it off, though, by getting x by itself. What? No. Bad. -2 plus or minus 5. You can't just get one answer and then say plus or minus that answer. Because what's -2 plus 5? 3. What is -2 minus 5? So I will list both of my answers as 3 and -7. Or 3 comma -7, or use a little ampersand in there, or whatever you can do. Okay, I can't just solve it one way and then write plus or minus. Because I have to remember that it's plus or minus 5, but that plus or minus 5 is getting moved over too. Like this. Okay. So if it can be written as a perfect square like that, you can solve by square roots. All 4 of these can be written as something squared. Some of them are nice, some of them are not so nice. Let's see if you remember how to factor perfect square trinomials, because we did that in section 4.4. Go. Whatever's on the right, leave it there. How about 6 and 6, because it's supposed to be something squared? That's the whole point of this. They're all perfect squares.
Which one did that do?
All 4.
All 4.
Very confused.
No. Y'all, please don't overthink this. Okay? These are all perfect square trinomials. We learned how to factor those. Remember, are A and C perfect squares? Yes. Does it have a middle term? Cool, it's something squared. Take the square root of the first term, square root of the last term.
For this one, would I do -1/4 or divide the whole thing by 4? Like that? Or just...
Math is communist. What you do for one, you do for all.
Okay.
Treat it like our old absolute value equations. Set it equal to 4, set it equal to -4.
Oh, that's it. Okay.
Okay, for 12, if it equals both a positive and -4, maybe solve them separately like our old absolute values. 4x plus 1 is 4, and 4x plus 1 is also -4. Okay? It's plus or minus 4. So just like our old absolute value, kind of do a light side, dark side thing. You can't just say plus or minus the one answer. Because 4x plus 1 now equals a positive 4 and a negative 4. So solve them separately. Okay, I'll run through them individually. Because either we're getting it or we're struggling. Well, factors of 36 add up to 12. 6 and 6. That means this is a perfect square trinomial and can be written as x plus 6, a quantity squared. Square root both sides. Plus or minus 5. What you're really doing here is saying x plus 6 is 5 and x plus 6 is negative 5. Okay? So you can do it like that, or just a little bit of mental math with it. It doesn't matter. You're still going to get the same two answers. Okay? I show that because sometimes you have to write it out like that. Remember our factoring decision tree. Is there a greatest common factor? Between 16, 8, and 1. No. Are A and C perfect squares? 16 and 1? 1 squared is 1, 4 squared is 16. They're both perfect squares. Head down that path. Is there a middle term? Yes. That means I can write this as something squared. That something is square root of the first term, square root of the constant, always shares the sign with the middle. If I need to FOIL it out to be sure and take 4x plus 1 times 4x plus 1, it should equal this, if I'm right. So, we square root, getting plus or minus 4 is 4x plus 1. You're saying that 4x plus 1 is 4. And 4x plus 1 is negative 4. So you need to solve both parts. With that shown, what about this one? Yeah, don't move the constant. Don't move the constant or no, this all just craps out.
So you square, you get 4x plus 1 squared, right? Which, if you were to factor that out, it would be 16x squared plus 8x plus 1. So you put 7 equals 16, and then you just square both sides. So you get 4x plus 1 equals plus minus 4. And then just solve.
Yeah, that was it. Yeah.
5x minus 3. Yeah.
Okay.
Well, if you're trying to move the constant over and set it equal to 0, you're missing the entire point of this. In which case, the slide immediately after this is going to make 0 sense. The purpose of this is I can undo squared with square root. So try to write it as a squared. If I can write it as something squared, then I can undo that with square root. Never write your answers like this. Leave them as actual rational numbers, 17 and negative 7. Okay. So far, all of these would have been factorable if you set them equal to 0. I understand that. We're trying to set you up for when they're not. We're doing this when everything is pretty, so that when I just start pulling random numbers out and all of your answers have radicals in them now, you can handle it. Okay, one more. Is there a greatest common factor between 25, 30, and 9? Are A and C perfect squares? Write it as a perfect square or as a binomial squared. 5x, square root of this guy. 3, square root of that guy. Keep the middle term, or middle sign. If I have something squared, I can undo that with square root. Now, I can set this into two separate equations here. Is anyone okay with just ugly expressions? Like this? And then do the mental math. 3 plus 9 over 5. 3 minus 9 is a negative 6 over 5. Okay. You can either do it like that, or you can turn that into 5x minus 3 is 9. And 5x minus 3 is negative 9. Okay, either way works. One involves a little bit of mental math, the other one involves a little bit of writing. It's whatever your preference is. But I have to have a perfect square trinomial in order for this to work. It's not always going to be a perfect square trinomial. This is a visualization of what is called completing the square. You did it back in Algebra 1. It's been a long time. But the idea is, if I wanted this to be a square, it isn't, right? So I'm going to chop this up, and I'm going to take this rectangle here, and I'm going to put it up here. That's what the next part is. I cut that B in half, that wedge, and I put it up here. See, the problem with that is I'm missing this little square in the corner. I'm missing whatever the perfect number is that's going to turn it into a square. If you all look at visual area, length by height, base times height, length times width, whatever you want to call it, it's b over 2 times b over 2. Half of a b times half of a b. But once I put that b over 2 squared there, now look at what each side length is. X plus b over 2, x plus b over 2. X plus b over 2 squared. This is called completing the square. I find the magic number that's going to make it work. Down here, I want you to write what this is going to be. This magic number right here, b over 2 squared, is always based on this. Whatever b is, take half of it, square it. That's the magic number that makes it work. Always. And then after that, I get to write it as this perfect square binomial. This number will always be half of this or the square root of that. It's both simultaneously. It's half of the middle term and the square root of the last term. It is perfect. I have completed a perfect square trinomial. It sounds so much more complicated than it is. It's not really that hard. If I want to know the perfect number for this, x squared minus 10x, I'm asking what goes right here to make this a perfect square trinomial. I need the number such that this will make this. Okay, all of this should be true if I find the magic number. And the magic number is always b over 2 squared. Every time. So right now, what is b? Negative 10. What's half of that? Negative 5. Square it. 25. 25 is the number that completes the square. Because now I could write this as x minus 5, which is x minus 5 squared. Okay? But I needed to know what that perfect number was in order to make this work. Because now, can't I square root to solve? But I can't do that if this is 20. I can't do that if this is negative 15. Okay? I can't do square root stuff if it's not a perfect square. So I have to make it a perfect square by completing the square. Find the magic number that goes in that square. Okay? Now sometimes it's nice. Sometimes it's not. 14. What's half of b? Squared. 121. Okay? They're not always going to be nice like that, though. What's half of 5? Ew. 5 halves. Because you tell me, is it easier to square this, or is it easier to square this? Do you know off the top of your head what 225 squared is? 25 squared is 625. Are you going to know that that's 6.25 off the top of your head and then turn it into 25 fourths? But if I write 5 over 2 as just 5 halves, when I square 5 halves, it's just 25 fourths. It makes it easier if you leave it as a fraction. Let's see what you can do with the others. 18 and 19, you got to do a little more thinking. Because b over 2 squared isn't going to work for those ones. 18 and 19, you got to do some guessing and checking to see if you can find the perfect number. Okay.
So if I'm doing that b here divided by 2 squared, would it just be 25 here?
It has something in A.
But then this
That's
one
what A
is
is.
a.
And that's where we're headed with this. Is whenever there's an a value, it completely screws it up.
I don't know what to do past
It's
this.
definitely better because it has.
Okay.
Oh,
Listen
two.
to Callister, not two.
Not two?
Um,
Okay, I was just checking in my head.
Okay. If it's a perfect square, you know that it has to be 5x, right?
Is it just one?
So what's going to go here
You're right, upside down.
to make that squared?
I'm
Well,
gonna try to.
25 was way too big, right? So try smaller. Okay, Callister said 2. Can I do 5x plus 2, 5x plus 2, and it comes out with this?
All it is basically what he did.
And there's my 25. There's 10. There's another 10. And then 4. So I'd have 20 and 4. That's way too much.
Yes.
Because it's not going to match here. So if this is too much, try 1.
Okay. Okay. Alright, that's not quite what I got.
25, right?
Okay.
So I got 25.
For 18,
Five.
for 18, do 1. 1. Because, think about it.
Right, because you got to...
Yeah.
Okay, I don't really know how to explain this.
So that's
if you have
10x in the
5x
middle.
He said guess and check, right? And I tried
And
2,
then
it was too
that
big.
one would just be 1.
So 1 is your magic number.
How do you check it? You just
I'm so confused, but yet
do
I
like
understand.
put it like
We're
back-
we're going to make... There's an algorithm to do
My main
this.
question is, how did they know how to make all those architecture back in like the 10th century when they were making all those cathedrals?
No, because it has a term in front
They
of
don't have
X squared.
calculators, so how did they figure that out?
X squared.
A lot of proportional reasoning and brute force math. Okay, I'm guessing that half of negative 30 is negative 15 is squared is 225. I'm guessing that's not hard. Okay, what is half of a half? A fourth. And a fourth squared is, okay. In these ones, it's going to be something squared at the end of this, right? Like this is going to be x minus 15, the quantity squared. This is going to be x minus 1/4, the quantity squared. Right? So I'm going to have something squared here. I know it's going to be a 5x right here. How do I know that has to be a 5x? Right? Square root. The question is, what goes here to complete this square such that I still have a 10 in the middle? And that's where a little bit of guess and check might come in. So if I put a +1 here, that's square the first term, square the second term, multiply and double. Sure enough, it got me a 10x in the middle. And my constant at the end tells me what number is going to complete the square. Okay, it is 9. Because, does this come out to 2x minus 3, the quantity squared? So what I want you to get out of 18 and 19, what was different about those two compared to the others? The a value. If the a value isn't 1, think back to our factoring. If the a value wasn't 1, it became a lot more difficult, right? There's like 5 more steps if a isn't 1. So that's going to be step 1 for us to completing the square as an algorithm, is to get rid of a. We used to call it eliminate the Canadians. Get it? Get rid of a. Yeah, they're a. Actually, that's more like just northeast North Dakota, but I want everyone to write out. There's going to be steps to these. Step 0. There is a step 0. Okay. Step 0 is if you can divide everything, just GCF style, old school, do it. Because then you might be able to just, no, actually then you can't even do it. How do I want to write this? All right. I'm going to say steps 1 and 2 are interchangeable. Okay. First one is eliminate the Canadians. We're going to divide everything by a. And step 2 is going to say all, like a middle school dance, all the boys over here, girls over there. Variables on the left, constants on the right. And these are interchangeable because the order you do them in won't change what happens next. So step 1, divide everything by a. If I divide this by a, divide this by a, divide this by a, divide this by a, 0 divided by 3 is still 0. Variables on the left, constants on the right. Aren't I trying to find the perfect number here? Well, he's in the way. Get him out of the way. You're in my spot. Okay. If I'm trying to complete the square and something is in my perfect square spot, move it. Right? If I need to park close to the door because I'm on crutches, tore my ACL, uh-oh, going to be hobbling around like this for the next 3 weeks, then don't you got to make sure someone isn't in your spot?
Yeah.
Okay. Step 3. This is the actual complete the square part. Is you're going to add b over 2 squared to both sides. The reason I say to both sides, well, it is an equation. I still want to balance. So what is half of negative 4? Negative 2. Square it. So I'm going to add 4. You see why I say to both sides? I still have to maintain my balance.
So x squared minus 4 plus equals.
Write it as a binomial squared. It's always going to be of the form x plus b over 2 squared. Just like that first slide that had the little rectangles on it. What factors of 4 add up to negative 4? Negative 2 and negative 2, right? So I can write it as x minus 2, the quantity squared. This number is perfect because this number is both the square root of c and half of b. That's what makes it perfect. That's why we say it's always going to look like this, x plus b over 2 squared. Don't confuse the signs. B was negative. So when I say x plus b over 2, since b was a negative 4, negative 4 over 2 is negative 2. Okay? And finally, I can solve by square roots. If I square root this and I square root this, we got x minus 2 is plus or minus square root of 2. Can I simplify the square root of 2? So when I add that 2 over to the other side, my answer stays ugly. This is called a compound number. A compound number is going to have a rational part plus an irrational part. So like 1 plus square root of 5 is a compound number because 1 is rational and square root of 5 is irrational. I'm going to leave my answers like this because they're the most accurate. 2 plus square root of 2 is one of my answers. 2 minus square root of 2 is one of my answers. Now, those aren't pretty. Again, I go into Connect with those numbers and they're going to look at me funny. So if you wanted right next to it to say approximately 1.421 is square root of 2? Someone check it. Square root of 2, 1.412, I think. 414? Oh, okay. And 2 minus that is going to be about 0.586. Okay. The red stuff is my actual answer. That's the real answer. The white stuff below that, that is the approximation of the answer. That's what I'm going to say if I'm trying to graph it, because I can ballpark about 3.4 on a graph. Not many kids are going to be able to ballpark 2 plus square root of 2. So the red stuff is the actual answer. The white stuff is the if I need to graph it or I need to say it in the context of a word problem. I'm going to do it again. I'm not just going to set you loose. I'm going to do it again, but now I'm going to leave the steps there. Remember when I said that these two are interchangeable? I probably don't want to go dividing by a if the whole thing's mixed up like this, right? So I'm going to start by getting my variables on the left and my constants on the right. I'm going to subtract x over, and I'm going to subtract 3 over. Okay? Variables on the left, constants on the right. You see how I got that blank space for my perfect square number? Before I go finding my perfect square number, I've got that a value is screwing everything up. So divide everything by a. Now I want you to see where I have it right now. Cool. What if I had left my order? What if I had divided by 2 right now? I'd say x squared minus 1/2 x plus 3 halves is 1/2 x plus 9 halves. And then I would subtract half an x. I would subtract 3 halves, getting 6 halves, which is 3. I still get there, but most kids aren't going to want to deal with fractions if they can avoid it. So I want to show you that you can do it both ways. Steps 1 and 2 are interchangeable. You do which one makes sense for you. Now that I'm here, it's actually not too bad. Add b over 2 squared to both sides. What's b? Over 2. Negative 1/2. Careful. Square it. 1/4. So now I can write that as a binomial squared. The binomial is always x plus b over 2. So in this case, b is negative 1. So negative 1 over 2 is 1/2 squared. 3 1/4. Y'all remember elementary school? Multiply these two, add that one. 13/4. Now there's a benefit to leaving it as a fraction. If you call that 3.25, you're going to have some problems on your hands. But if I leave it as a fraction, look at what happens when I square root. The square root of a fraction is a fraction of square roots. And the square root of 4 happens to be x minus 1/2 is plus or minus square root of 13 over 2. This is why we had to step back and review the radical stuff. Imagine if I had tried to just jump straight in here.
That would have not been too nice.
Okay. Dang, dude, when are you rocking that Taco Bell for lunch? Add 1/2 over. 1/2 plus or minus square root of 13 over 2. Again, I have a rational part and an irrational part. 1/2 is a rational number. It's a regular fraction. Square root of 13 over 2 is not a regular fraction. It's got a radical in it. It's an irrational number. compound number. Rational part, irrational part. Okay? You're also not Scooby-Doo nose. Okay? It might have been a while since you've seen this. And by a while, I mean for some of you, this has been, what, 3, 4 years? 2 years for sure. So, we're going to start small. We won't even have time to start small. Guess what? No homework. Okay? Because tomorrow I want to come in and just hit this running. We're going to practice this with nice numbers. We're going to practice it with gross. I'm just going to pick numbers out and say, here you go, have fun. Okay? You have to be able to do this. Everyone should have gotten their quizzes 1 through 4 back. There was no awesomeness that I observed, so sorry. And I can't give quiz 5 back yet because I've got 2 kids who still have to finish. No.